Great. So I started with a short story. So in 2007, a certain Dan Baines from the UK made a very peculiar April Fool's prank. They posted a picture of supposedly mummified fairy, like Tinkerbell, like a very funny and very old and very dirty Tinkerbell. And the post started spreading like wildfire. People started believing it so much that the author had to release a note saying that it was all just a lie, just a silly April Fool's prank. And what happened next? Well, many people got angry because they claimed that the fairy was true, and now Dan was just trying to cover up the truth, right? And then came the elections and the pandemic, and misinformation goes well beyond pranks and fairy tales. It has real effects, right? Psychological, physical, it harms people, it kills. And this presentation is about how it all works and how we try to help with NLP to fight it. As a short context, I'm Gabriel. I was born in Brazil. I studied in France. I joined Google in the UK and transferred to Switzerland. Now I'm struggling with Swiss German, Caesar pointed. One of the coolest projects I did was joining google.org in the UK and worked on a fellowship along with Full Fact. Full Fact is a fact-checking agency. They are one of the big players in the UK for the fact-checking world. And the project was part of something called the AI for social good. The fact that I'm talking to you about this is a strong hint of how cool it was. Right? And to talk about it, this is how I divided the menu today. So we're going to start by how fact checkers work and how we could help. And of course, go through the NLP part. And in the end, I've heard they prepared some virtual snacks and champagne, if I heard it right. Let's get started. So as we saw in the fairy case, lies can spread super quickly, notably much quicker than truth. Also, for each one piece of truth, we could invent an uncountable number of lies. It's not a fair competition, and people already knew it centuries ago, even when they look good, like in the latter case. The fact that everything moves so fast, like social media and internet today, only leverages this lack of balance. And one big problem is that fake news can be designed. They can be offered with as many cherries on top of it as one wants. And to be more persuasive, they can adapt it to context. They can fit the target. They can mutate in time. And yeah, since they often have intentions behind them, people may be willing to throw lots of money for it to spread quicker. In the end, it may convince people that fairies exist, right? Or not, but it may at least create a feeling of very suspicion and uncertainty. So they relativize the truth. Now, before we continue, I have a small challenge for you to think about. Please don't say it out loud if you've seen it before. It's quite tricky. I want you to quickly think about which of the gray lines is longer. And let's go on. You can think about it. So there's one big issue on top of the cherries. Firstly, once we adopt a vision, we tend to privilege facts that support it and give less importance to contradictory data. This is called confirmation bias. And it can be even worsened by the filter of a bubble effect on social media, for example. Another effect is called cognitive dissonance. I think a simple illustration is the tale by Aesop about the fox and the grapes. So there's a fox who really wanted to eat grapes hanging from a branch, but it couldn't really reach the grapes. And after many, many attempts, the fox finally gives up and says, oh, never mind, they were sour anyway. So to put it shortly, we tend to prefer comfortable information to precise information, right? And this is a problem with fake news. Finally, there's something called the continued influence of effect of misinformation. We may fix one or two pieces of evidence, but all the wires in between may still be compromised. So what we take as conclusion is that with so many biases on the table, saying true or false to a piece of news is simply not enough. Fact-checking has to take us by the hand and like visit the story from the beginning and tell us the newer version. It's an art, basically. So did you decide? Well, the one below looks bigger, right? And it actually is bigger. But maybe if I presented it as a challenge, you may have been biased to simply thinking it could not be trivial. So in a way, you may have been biased. This is just a silly toy example, but real life can be super tricky in a myriad of other dimensions, directions, and styles. Let's see how fact checkers work to help us here. Not everything that you say can be checked. Among all the things that are said, only some of them are actually claims. Like a question is not a claim. It's just something that is said, but it's not a claim. And among the claims that are saying something about the world around us, not all of them are verifiable. So there's a small set of verifiable claims. Maybe they're just out of scope, or maybe they're just personal statements, for example. The ones that are verifiable are the subject of fact checkers. But unfortunately, they don't come color-coded in blue, orange, and green, right? For fact checkers. There's a lot of irrelevant information in the way, and it has to be filtered out in order to access the verifiable part. Finally, even after filtering out all the relevant information, there's still hundreds of thousands of verifiable claims every day. So this green set is huge, especially compared to the time budget of fact checkers. They're not many. They have a really tough work to do, and there's just too many verifiable claims to look at. So how to better allocate this time, amount of time? You could say it's the knapsack problem. And let me give you a quick reminder. The knapsack problem is a famous computer science problem where you have to select what to put in a bag. Maybe you prefer a big item that means a lot to you. Maybe you prefer more items that are individually less important, but together sum up to something that is more worth your backpack space. If you think that each claim has an importance, but consumes some of the available time, we can ask ourselves, which are the claims that should be in the fact-checking backpack? But unfortunately, it's not that simple. Claims don't come with pre-computed values for weights or importance. And we could argue that journalist expertise could check these boxes. So let's just assume that for now. Even though there's a bigger issue, there's just too many claims to pick from. So without seeing all the claims, how could they even have the chance of making a good decision? Well, if only we knew some company whose mission was to organize the world's information and make it universally accessible and useful, that could help. And that's exactly Google's purpose. Of course, we still have to solve the next step problem after that and actually do the fact check, which is quite tricky. That's not trivial, but it should also be covered by the expertise. Let's see how we helped. We can divide the process of finding claims into three main stages. We collect the data, we treat it, and then we make it available for exploration by the journalists. After that, the fact checker does research and eventually publishes the article. We were happy to help in many ways. Firstly, we organized code repositories, deployment, version control, and all the infrastructure for development. We also revamped lots of pipelines for collection, enrichment, and we used more efficient indexes, storage methods, made extensive use of cloud. And of course, these more efficient systems allowed us to incorporate more data sources, which now include even live radio transcriptions. We also supported internationalization in the data, structures, and storage, so that the platform could be easily adapted to fact checkers around the world. Finally, of course, tons of NLP allowed us to navigate through the claims based on content and to extract quotes, to put things into context, to provide fact checkers with some badass advanced filtering. And this was essential for them. But let's focus a little bit on NLP because that's the name of the meetup, right? Okay, so important people are important. No need to say that, right? Everything they say is magnified. So they better not say anything silly, right? It's not really the case today, but that's why fact checkers have to pay particular big attention to these cases. But how to look for what important people say? Well, if we search for President X, we're going to get lots of text about President X. Sometimes it's President X saying something. Sometimes it's just a mention. Many cases would be missed because President X was written in another way, like a nickname, a pronoun, like here you have her. And then we would lose many of the content, much of the content, yeah. So we developed a model to detect someone saying something. It's called the quote detector. There are many different ways to write that, and many nuances. So it's quite challenging to make something robust. Here you go. According to her, the vaccine will be available by the end of the month. So President X said it, and we're trying to detect it as a quote. It could have been something like, the study was conducted according to guidelines, and then according to would not mean quote. So there's lots of small details that we have to take into account. That being said, we're particularly interested in the person who's making the claim. So that's something we try to detect. The speaker, the claimer. And then we have to find and link all the elements in the text that are relevant, the entities, right? So President X is something. It means something in the real world that you can relate to. Differently from spoke, for example, or yesterday. These are just side words in this sense. Given the text and some context, we can then map the entities to a specific element in a database. And this is called entity disambiguation. So this step is crucial because maybe President X is the name of a superhero or the name of a song or just the role I invented for this example. With this information in hand, we can link together all the claims in which President X is mentioned or says something, and then we can explore it in a very rich database, which is based on content. And we can find everything that President X actually said around the available pieces of news. Let's take a look at the first model, the quote detection, which is my personal favorite. So the quote detector is a token-based, BERT-based trained classifier. It has precision and recall specifically for the task of detecting the claimant of above 90%. And as far as we could tell, by the moment it was developed, this was the state of the art. We embedded many explainability tools into it. So some keywords, scores, this beautiful debug interface with a giraffe on it. And it also detects something very special, which is so as I mentioned, the keywords, because they help us know what the example, how it was said. So it goes beyond the simply finding a binary classification of is it a quote or not. It actually knows why it's a quote. So it's said that's, in this case, the keyword, but it could be according to, like in the previous example, or it could be something different. And possibly having said is quite differently from strongly affirming or something like that. So this is quite important when classifying what kind of quote you have as well. On top of that, we added some cool debugging, collab notebooks to control the whole pipeline. We added a detailed documentation for training, for handling data, for exploring the model and the data. So this is the quote detector. Just because it's super cool, these are the classification scores for a sentence that was not present in the training data along the training epochs. So you can see as the model learns to classify this. In the beginning, it's completely random. And as it learns stuff, then it's able to classify that French citizens in Haifa should exercise caution. The French ministry has had in a security update. It's surprisingly updated, even though it's from 2019. And we can see the French ministry is the claimer. French citizens in Haifa should exercise caution is the quote. And the comma and in a security update are just appendices. And has said is actually the cue. Okay, so for entity recognition and co-referencing, we could use off-the-shelf services in Google Cloud because we had moved everything to the cloud. And since new entities appear and change very frequently, it would spare us a lot of maintenance. Like the news have this very useful characteristic, which is they are very up to date. So it also means that it's quite challenging to keep all your systems up to date as well, because it's always moving. So having third-party services as much as you can help you a lot, offloading this maintenance cost. For entity disambiguation, we went a bit further and cross-checked the data against wiki sets of alternative names. This way, different ways of addressing like the same person are correctly resolved to the same entity. Remember, and finally, once all the preceding steps are done, we could jump into clustering. The information that a claim contains an entity is quite meaningful. If we build this graph for a bunch of claims and entities, so like a claim contains an entity, it would naturally cluster the information and be quite useful. Then by looking at the entities present in each blob, so here we have 4 blobs, it's quite easy to have an idea what the main topic is. So in this case, these topics were all around Brexit, Trump, sports, and Love Island, which is a British reality show. Yes, you can ask me later for the claim connecting Trump and Love Island. That's quite interesting to see. But well, this is all quite useful for fact checkers because they can easily navigate to the clusters they're interested in. And they also have an idea of how each cluster conversates with the others. Also, the connections in the graph can include much more information, like entity said something, and basically this contains verb, could be any other verb that we could basically create according to the data we have available. So in the case of a fact checker interested in Brexit, we could simply not lose any time with these other unrelated topics. But well, it's important to make sure that this all works well in different contexts, and bias is a very present problem when we talk about machine learning. For that, we matched all the Google responsible AI practices and the pair guidelines for our models. One of the most important aspects here is human-centered design. So we were constantly interacting with the fact checkers and getting feedback to tune the model. To make this process more efficient, we incorporated a handful of explainability features as we saw. And with those scores and the results, we could many times iterate with the fact checkers and tune the models and use their expertise to detect any bias in the final results. Focusing on key elements like the keywords and all the other explainability items also helped a lot, because, well, when you focus on keywords like the verb said or according to, etc., you have less dependence on group names, specific content, so you kind of reduce your chances of biasing. And next, we have redundancy in the data, because when something important is said, it's likely reported in more than one source at the same time. So if we don't catch it in the first one, we could catch in the second one, for example. And finally, but definitely not less important, we partnered up with Sylvia, an outstanding linguist who prepared a report on how the model behaves, what are the strengths and weaknesses, and produced a detailed performance report, which is the main guidance for any on how to use the model properly and how to improve the model if ever we need in the future. So let me wrap this up. Thanks to all those technologies, a fact checker can easily find out what the trending topics are and what people are saying about it, what other people are saying about it, what else did these people say, and they can filter by any other criteria that we scrape from the data using NLP. This means that they have access to a much higher level of abstraction, and they can operate much more efficient on this new level. I think this is crucial when confronting that super unbalanced challenge we have talked about. And we can measure these effects in many ways. The positive effects, here are some of them. So the number of claims detected increased 1,000 times. And what do I have to say about it? So in my opinion, I think that most importantly, this is all about what technology should be. Empowering people with good intentions to create positive impact. So I don't see a better use of technology, and in particular NLP, than this kind of applications. Of course, before we jump into any discussions, I wanted to double thank the organization and all the wonderful people who participated in this project. So Alex, Alper, Amanda, Anand, Andy, Ben, Brandon, David, Ed, Florian, Manassis, Simon, and Anna, and Jen, and Rasmi. and all the other ones to help directly, indirectly. And please ask anything you like while we jump into the nibbles and drinks. And I'll leave some here. There you go. Thanks a lot.